Welcome, everybody, to the TheWellMan'sPodcast. This is episode 69. Brian and I are really excited today because I have one of my co-workers, one of my docs that works at my clinic, the Naturopathic Health Clinic, on today. And she's an expert in neurological disorders and especially like Parkinson's disease and multiple sclerosis. Today, we're going to be talking about MS or multiple sclerosis. And just a little bit about Blake. She's a graduate of Salem College. And by the way, Salem College, if I'm not mistaken, Blake, is what the oldest all-female college in the country, which is crazy, right here.
Yeah, that's right.
Yeah. And there you earned, you studied biology and chemistry, right? And from there, you then went to, I think you had a little bit of a break, but I think from there you did your medical training at Bastyr University in Seattle, where that's my alma mater also. And you specialized more in neurological diseases. And then what I find really interesting, and this is a rarity with naturopathic doctors, Blake is also published. She's done a few studies out of the out of LSU in New Orleans on multiple sclerosis and green tea and its effects on that. And then the thing that I really truly love about Blake is that I'd say her second career or her co-career is that she is an artist, poet. I'm not even a painter, right? Singer. Yep. So that, to me, that's like a wonderful fit into medicine, because a lot of times in conventional medicine, what we've done, we've taken the art out of it. So Blake is one of those rarities that puts it back in there and really helps her patients and clients. So Blake, did I miss anything? Is there anything else I should mention about you? Uh-oh. Blake? Okay. So Blake, before we got cut off, I was just saying, is there, I don't know if you heard the whole introduction, but is there anything that I missed? I think I left off with the research that you did out of LSU, and talked about a little bit about your art background, being an artist. But is there anything else I missed or that we should talk about?
I think you pretty much covered it.
Okay. Well, look, I'm really excited about this one. It's something that I don't really know much about, but can you just fill us in on what is MS?
Certainly. Yeah. And thanks for having me on. So multiple sclerosis is a chronic inflammatory demyelinating disease. It's progressive, which means it will only get worse once the disease onsets. And the origin of the disease is one of neurology's sort of darling, controversial hot topics. Some people would argue it's a viral-based illness, and the reason for that largely actually has to do with the epidemiology of MS. So when you look at a map of a country and the history of MS incidence within that population, what you find is a sort of bullseye pattern, which means that it starts with one location in one spot and sort of moves out progressively. And that's interesting from an epidemiological standpoint because that's how viruses move the population. We don't really see that. Yeah, we don't see that with other autoimmune diseases per se.
Well, that's fascinating to me because so is that the conventionally minded thing? They're thinking it may be viral in origin?
Okay, so the population is the research population is divided into two camps.
Right.
So there's the inside out and the outside in, sort of competing theories. Okay. So the inside out theory is that, somehow these renegade lymph cells cross the blood-brain barrier of their, out of their own crazy accord and find their way into the central nervous system and sort of go to town on the white matter of the brain. Okay. That's the inside out model. the outside in model sort of suggests that, well, maybe there's some kind of viral, exanthem that found its way across the blood-brain barrier, made its way into the white matter, and did the thing that bodily invaders do, which is sort of leave a bread trail, of cytokines along the way, and then the immune cells follow the trail until they get into the nervous system and find their way to the diseased brain tissue, and then begin their attack and get confused once they're there between some of the ID tags or antigens on these viruses, and mistake it for what we assume is myelin basic protein. We're not sure matter. Which of... Yeah, exactly. So white matter has axons that are covered in these sort of proteiny, fatty, it's like insulation for wiring, right?
Right.
And so the immune cells get confused and think that some of those proteins are virus proteins. And so they start attacking the myelin, and maybe also the myelin producing cells, the oligodendrocytes that are kind of hanging out in that area. And then along the way, unfortunately, the axons of these white matter neurons get damaged, which is actually collateral damage. It's secondary injury that, if you're shooting at a power line, then you're going to hit both the insulation and the wires inside.
Right. Well, so that's fascinating to me, because when I was in medical school, there's this whole concept of MS being related to not getting enough vitamin D. Where does that play a role?
Yeah, that's a great question. Well, so it's hard to say exactly. Okay. And what I learned over at Bastyr was that, we're all just so vitamin D deficient in our society that, of course, it's going to pop up, in a lot of diseases. Because when it comes to vitamin D, unless you're basically, outside naked sweating in the sun all day, you're not going to make enough vitamin D, because we need the oily, deposits on our skin in order to do whatever magic it does when the sunlight hits you that helps with the conversion, right. That first step. So we're all deficient in vitamin D.
And I see that all the time with my patients, and I know you do too, when you actually run a test.
Yeah.
Right.
Yeah.
I mean, it's rare. If they're replete, it's because they've been supplementing.
Right. Oh, absolutely. Right. Absolutely. Yeah. And, places like the Pacific Northwest, where people are even less exposed to sunshine, seem to have higher incidence, or the population has a higher incidence of MS, which is also sort of represented globally. The further away you are from the equator, the more likely that population is to have MS.
Okay. And so
except in New Orleans.
Oh, is that right? Okay.
Yeah. Well, New Orleans has the largest population of non-white MS sufferers in, as far as we know, the whole world.
Wow.
Yeah. Wow.
Yeah. Okay. Yeah.
Okay. So that's bizarre.
Yep.
So all right. So we're talking about a correlation then, right? People, is that what we're talking about? I mean, there's no vitamin. If you're vitamin D deficient, it doesn't mean you're going to get MS.
Correct. It does not.
But there does seem to be some sort of correlation with it. But, I think of New Orleans, I think of that as being a sunny place.
It's so sunny that you can't go outside.
That's right. You burn your skin off. Yeah.
Yeah, absolutely. So people don't hang out outside until the sun goes down. So in the swamplands, they're sort of just as sun deficient as we are in the Pacific Northwest.
Okay.
Yeah.
All right. So has there been a virus identified or anything like that?
So this is kind of new as far as the last couple of years. There is a viral protein that has been identified. So it's a human retrovirus, basically. And it's an interesting, so that's a whole, I guess, genus perhaps, or maybe it's a species with subspecies. I'm not sure what the
Right.
categorization is, but basically the there is a viral protein that has been shown both in vitro and in vivo to be pro-inflammatory. And this one, it's just called the MS retrovirus. It's not a very creative name, unfortunately. But it has this really funky viral protein, ID patch on the outside that is present in, histologic samples of MS brains, post-mortem experimentation, obviously. And it's not there in healthy controls. And so is this maybe the thing? Possibly. But the concentration of the protein is very low. So the argument is, well, it's such a low concentration that it couldn't possibly be a causative agent. It must be one more corollary, step, rung in the ladder, so to speak.
Right.
But I don't know if I mean, with our training, we learn about, very strange kinds of science like homeopathy, where a very small amount of substance can have very profound effects. So I'm not as ready to dismiss.
And hormones too, yeah. Yeah, I mean, very small amounts of hormones have very profound effects on the body. So yeah.
Absolutely. And an interesting side note, just as a shout out to homeopathy, not that I'm a huge proponent, homeopathy makes my scientific brain hurt because I've seen it work and I can't explain it. And I can't handle that. I read a study recently, though, that arsenicum album, the homeopathic arsenic, was injected as an antidote into these rats who had been seeded with arsenic. And so the controls were just given arsenic. I can't remember if it was sub-Q or IM. And the study rats were given, arsenicum album as a remedy, and they survived, and the control rats didn't.
Those studies are fascinating to me when I hear about them.
Yeah.
But you're getting back to what we were talking about. You're talking about a very small amount of this protein, and what I'm gathering is we don't really understand the disease, right? We don't really understand what causes it. Yeah. Okay, so then I guess my next question is, if somebody has this, what are the signs and symptoms of this disorder, and what is the progression of it?
Yeah. So first of all, when I first started studying MS, I guess the data kind of showed that women were, had a slightly higher propensity toward getting MS than men. Nowadays, there's actually a 1 to 2 female to male ratio of occurrence, which is really interesting because it's flipped, in the last 10 years. And so that's first. And usually people who get it are in their 20s, maybe 30s. And it's, in most diseases, if there's a younger onset, it's kind of a hallmark for a worse prognosis, a more severe disease progression. It's not the case in MS. The younger you are at onset, the better the prognosis is. Okay. Which is just totally bizarre and backwards from all things, right, typical in medicine, right? So very, very often the first signs of MS are some kind of vision change. It can be a painless, unilateral, double vision, blurred vision, maybe loss of peripheral vision. Other times it initially manifests as sort of cerebral issue. And of course, it depends on where the lesions are. Where the lesions are in the white matter will determine what your symptoms are, which is why it's a great pretender. That's why it can look like lupus or celiac or B12 deficiency or, neoplastic syndrome or something, because it just depends on where the critters land in the brain and go to work, right?
Okay.
Right. So typically, you're going to have balance issues, vision changes, unilateral at first. It often does progress to the other side.
So all the symptoms are on one side of the body, typically, when it began?
Typically, yeah.
Okay.
And actually, once you start having things like progressive weakness and sensory deficits, it's arranged by dermatome.
Mm-hmm.
Huh.
Yeah.
That's interesting. Okay.
Because it's very specific to where the lesion is.
Right. Exactly.
So then so if you have these symptoms, then how would it be diagnosed conventionally?
So conventionally, there are, there's the McDonald criteria. And long story short, the best way to diagnose it after clinical symptomology is sort of documented is going to be an MRI.
Okay.
And so, because the magnetic resonance allows us to look inside the skull, into the soft tissue, we can kind of get an idea of, is there a lesion? Is there not a lesion? And
that's
then
what we're looking for. We're looking for lesions for to diagnose it.
Yeah, you're looking for lesions. You're looking for. So in the brain, we have these ventricles that sort of drain the cerebrospinal fluid, and MS lesions exist sort of around the periphery of these sort of butterfly-shaped ventricle structures.
Right.
And so they're at the anterior and the posterior horns, which is not an anatomical term, but that's, what they look like. As we at the lab that I worked at, we went through thousands of MRIs of patients' brains, and they all have these lesions that are sort of at the hump of the butterfly wing, sort of, and other places too, but those everybody has. I mean, pretty much it's ubiquitous in the disease.
Okay.
And then there's also a cerebrospinal fluid assay where you do a lumbar puncture and you look for lymphocytes basically in the cerebrospinal fluid.
And they shouldn't be there, right? If you're just looking for the presence of them. Yeah.
Correct.
So you're talking about the central nervous system primarily, but do you see lesions in the periphery? Peripheral nervous system?
Not really.
Okay.
Yeah, that's a great question. No. So we see lesions in the brain and the spinal cord. And the research I participated in kind of stopped at the base of the skull. So we didn't actually I've seen some of the spinal cord lesions in the studies, definitely not in the periphery though. Yeah.
Okay. All right. That's interesting. So it's pretty common, right? I mean, considering, or it seems to me to be, because I've had a number of patients who've had that diagnosis here at my clinic, and I actually have a few friends outside of the clinic that I know that have it. How common is it?
It's fairly common. I mean, I think that something like, I think the number that I seem to recall is something like 200,000 people are at least affected one way or another by MS every year.
Wow.
And maybe that number is larger. Maybe it's more like 400. It's been a while
since I've looked. It just seems to be more common than what I've read. What about the progression of it, Blake? Like, does it progress in different ways for different people? Is it curable by any means, or is it not considered curable?
That's a great question. So, you know, technically it's not curable.
Okay.
It is certainly more manageable these days than it was, 40, 50, 60 years ago, when the only thing that seemed to work was actually to induce a fever. There was a time when there was this kind of experimental process where they would induce a fever, which goes back to, sort of the whole viral model. Because once you initiate that cytokine cascade, of a viral infection, it sort of wakes up the rest of the immune system. I got to go and figure out where this, viral breadcrumb trail is coming from. And, all of the repair mechanisms that follow the initial inflammatory insult are able to ensue.
Right.
And, so my grandfather had MS long before I came along. And one of the family stories is that he was suddenly lucid one day out of the blue when he had a fever, and he regained his ability to speak, which is, and right, because he had lost motor control, so that's really interesting too, because that speaks to the sort of not lack of axonal damage. The axons are still damaged collaterally, but not irreversibly. So I think that remains sort of a hopeful piece even today, where, depending on the degree of damage, even if the damage seems profound, it could still be reversible.
So people, and I hear about like remission with with MS, right? Like people will seem to go in and out of having symptoms too. Do you think that that's playing a role there?
Yeah, it's hard to say. I mean, the brain is this, right? I mean, this whole neuroplasticity, this ability of the brain to sort of go around roadblocks is really amazing.
And is that what they're thinking, Blake? They're thinking that plays a role in having people go into remission a little bit?
Well, more like, sort of if there's recovery from symptoms.
I see.
So there are different types of MS. There's progressive, there's primary progressive, which probably is the worst prognosis. There's secondary progressive, and then there's remitting relapsing MS, which by definition, you have, one of these attacks in the brain, and then the flare will die down. And oftentimes people will make mostly a full recovery. Sometimes there can be deficits.
In the remitting relapsing form of it.
In the remitting relapsing form. Now, there is some research out there right now that is suggesting that, maybe the secondary progressive MS is just a later stage of the remitting relapsing, and that eventually, as we age, typically our immune systems get weaker anyway, so perhaps whatever forces that are keeping it at bay are exhausted after however many decades of disease, and it just kind of turns into a more runaway version like secondary progressive MS.
Okay.
That's interesting about inducing the fever to me, because I know about like Uthoff's phenomenon, where if they're like, for instance, in physical therapy school, we learned about Uthoff's phenomenon. So if you exercise and they get overheated, it can cause those symptoms to worsen. So that's just interesting that they induce a fever and that can cause the symptoms to get better, is what you're saying.
Right.
That's interesting.
Right. Yeah. Wow. Yeah. Well, that's a really great point, because, when you exercise, you have this sort of sympathetic burst at first, a sympathetic nervous system burst, because whenever we initiate exercise, our nervous system thinks we're running from a bear. Mm-hmm. And then, eventually, depending on how conditioned we are, parasympathetic can take over, and it's like, oh no, this is just that weird thing they do when suddenly they're running for 20 minutes. Right? and you're right, you know, when those people who have MS get overheated in any capacity, there's something, you know, I don't know if it's the vasodilation, and if it makes, you know, if the sort of added leakiness of all of the blood vessels helps to exacerbate some of the, you know, the transit of the cytokines or the actual lymph movement, right? We don't know. But the fever actually has a specific cytokine cascade, you know, a signaling molecule cascade, where the body's like, you know, there's actually something here, and we got to go figure out where it's coming from. So all of the sort of, you know, scavenging T cells get involved, and everybody's looking for the source. And once you start that initial cascade, there are other cascades that follow that seem to play into the inflammatory neurodegeneration process.
Huh. Can you mimic that, Blake? Can you mimic it with like a sauna?
Yeah.
Well, the sauna, so this is it, right? So, and again, great questions that I don't think we really know the answers to. There are some doctors over in Germany who work in like spa medicine, which, you know, is a whole part of their state health plan. It's really fascinating. There's a certain dermatologist I spoke with once about a different virus, about HSV. And, you know, well, what do you do with patients that you're trying to get to sweat that have HSV when sweating seems to give them these viral outbreaks? And what they said was that any virus can only take so much heat.
Yeah.
You know, before it starts to denature, it doesn't have all of the cooling and the protecting things. It doesn't benefit from us sweating. And so if you can tolerate or survive, you know, the process of exposing these, you know, the MS virins, assuming that that's what it is, theoretically, I could see how a sweat depuration protocol could actually sort of overwhelm the viral protein structure at some point. Of course, the problem would be that, you know, in the process of trying to survive, and, you know, first the little viral vegetations go nuts and really attack all of the local tissue before they finally die, right? So the heat is going to stimulate them until it kills them.
Right. And it's hard to get your core temperature up just doing sauna by yourself. You have to do it kind of I know in Germany at least, or from what I've read, you have to be in a really controlled environment and be monitored to get your core temperature up to where you need it to be. I mean, sometimes those core temperatures are up to like 104, 105, you know, whereas it's very hard to do that by yourself with a sauna.
Absolutely. And you know, 104, 105, that's when proteins start to denature, right? Like that's the whole reason that it's dangerous. That's the same reason that it might be effective therapeutically. So it's a really fine line. And yeah.
Right. But we're not aware. I mean, I'm not aware. Are you aware of any studies where sauna helps with MS?
Yeah. Unfortunately, no.
But theoretically, it seems to make sense based on what you're saying. But with that being said, Blake, so how do you approach a patient who has this? Like, what do you do specifically in your practice?
So for me, I find that there are often a lot of lifestyle, dietary, and emotional correlates that overlap in my MS patients. It tends to be, I've seen impoverished people, especially down in New Orleans, which is just full of outliers in every way. I guess that's where the jazz comes from, right? But, you know, it tends to be a disease of affluence, or at least it's kind of thought of that way. You do see, of course, people from lower socioeconomic status getting this disease, but, you know, it's an interesting thing. So oftentimes, people have a kind of hypercoagulative or dysglycemic piece of their health picture when they have any kind of neurodegenerative disease. I see type 2 diabetes, and I don't know, it's like the vitamin D thing. Is it because it's ubiquitous, or is it because it's actually a part of the pathology? I don't know. I don't know if we know yet.
Yeah.
But yeah, I think that there definitely, I'm trying to remember the researcher's name. There's a guy out of Dartmouth, and I'm doing him a great disservice by not remembering his name. We'll have to find it in editing later. But he did this great study on mice where, so there is a mouse model of MS called experimental autoimmune encephalitis, EAE. And he was able to take gut flora from these mice and put them as in, fecal transplant into normal healthy mice of the same species. And those healthy mice got MS.
Oh, wow. Okay.
Yeah. So, and it's interesting because, similar studies have been done with obesity, with hyperaggression. You can actually take a really angry rat, extract his fecal contents, give it to a very passive, a clinically passive, docile rat, and it turns aggressive.
Right.
And so, half our neurotransmitters are made in our gut, right? And whatever little variants of molecular structure that exists, maybe not in the neurotransmitters themselves, but much like, every gene needs epigenetics in order to work, I think that there's probably, sort of a supportive multitude of molecules that either maintain the structure of the neurotransmitters or help, sort of help with the function of them metabolically, which is probably also, that's why a lot of isolates and extracts don't always work so great. That's why whole foods are much better, right?
Yeah.
Because we need all of the supporting players for these pathways.
So what you're saying though is you're definitely, when you see a patient, you're going to be checking out their gut health then.
Absolutely.
I mean, that's like a main thing to make sure the gut is helping, and possibly using probiotics as part of the therapy. If there is an issue, right? Because you're restoring the healthy gut microbiome.
Absolutely. Absolutely. Yeah. And, the things that we feed the bugs in the gut as well. Right. Because I know there's a study on Bacteroides species that lives in our gut. And if we eat, a hamburger, the species will excrete a very inflammatory or pro-inflammatory type of molecule. But if we eat fresh fruits and veggies, this critter will sort of poop out a less inflammatory type of the same molecule. So it's all related.
Right. So, but still, we don't know. We're playing in the dark here. But as a naturopathic physician, it's like you're checking out the person, seeing where their weak links are in their overall health, and then adjusting with the focus on the gut, right? I mean, that's what it sounds like.
For the most part, yeah. One really interesting piece, just when I take a history from patients, often I find that right before their initial MS attack, there has been some kind of major stressor in their life. So cortisol spikes, which, as we know, also affect blood sugar and all of those downstream things, that seems to be also a major trigger. So you have to have the genetic predisposition And we do kind of know what HLA, the major histocompatibility molecules that come into play with that. Scientists have figured out pretty much, well, if you have this particular unfortunate combination of genes and you have these stressors, usually a history of smoking, obviously just because that makes the whole system less robust, it increases the propensity to actually get MS if you have all of these pieces in place. When you have that major stress storm, it can sort of trigger the whole thing.
Okay, that's interesting. So there are lifestyle habits that can make you more prone to it then.
Yeah, absolutely.
Right? Like smoking, well, it's certainly not going to help, right? I mean, smoking being one of them.
Yeah.
So, okay, is there any specific, like as far as nutraceuticals that seem to really help? We mentioned vitamin D.
Yeah, I mean...
Does that help, or would that, I mean, I guess it's one piece of the puzzle.
It's a piece of the puzzle, exactly right. So I'm completely biased because I did all this research on this green tea extract. So there's a molecule that everybody who studies kind of disease and nutraceuticals right now is really excited about. It's called EGCG, which is epigallocatechin gallate. It is a big, hunky, chunky antioxidant. And for those who don't know, antioxidants work by losing a piece of itself, one of its functional OH groups, right? So EGCG, yeah, it's a great antioxidant because it's got lots of pieces that it can kind of use to sequester free radicals. But it's also kind of this weird magical molecule that works intact or as a ligand, which is a molecule that interacts with a receptor, basically. So yes, it works as an antioxidant where it loses pieces of itself, but it also works as a whole functioning molecule to somehow wrangle in and sequester renegade lymph cells. We don't know how it works. It seems to be the case in a couple diseases where where T cells and B cells are involved, and so my thing with patients who come in with MS, I put them on fiber. I try to help heal their gut. I put them on probiotics like we talked about, and then I tell them to drink green tea. Now, drinking green tea, both as a naturopath, but also from the research that I did, these whole foods products, whole green tea, it has other ligands and antioxidants and polyphenols other than just the EGCG. And so as we begin to metabolize that big clunky molecule, we have all of these other supporting players to kind of help guide it down the metabolic pathway. When you take EGCG by itself, in an extract that's say, 75% EGCG, and then, maybe the rest of it is EGC, which is just basically the same molecule with one or two less OH groups. Sometimes, and not always, and I don't know why, we see hepatotoxicity.
Oh man. So that's what green tea supplements, like EGCG supplements,
run the risk of hepatotoxicity.
And so that was in what you found in the animal studies?
No, we didn't see it in the animal studies. We only saw it in the phase 2 clinical trial. We didn't even see it in the phase 1 clinical trial. So,
wow. So it wasn't an animal study. You started seeing it in people?
Yeah. But there were no liver toxicity issues in the animals. And I have to just explain that this study we did it was an open label study, which means we don't know where our EGCG was coming from. We don't actually know what was in the little capsule. For all we know, it could have been half sawdust from China. I mean, and that's a problem with open label studies of any kind, because it was a double-blind placebo-controlled trial. So I couldn't look. I didn't know, I didn't know, nobody knew. It was just, whatever randomized patient X, got from the pharmacy, that's what they took.
Okay.
I know that, there were AST, ALT elevations in
These are liver enzymes, yeah.
liver enzyme elevations in 2 to 4 out of our 20 some odd patients. Now, if these people were drinking alcohol, really drinking, that could also have, yeah. So we don't really know, but all, drug side effect profiles, we have to report a possibility of hepatotoxicity. So we don't know if it was the supplement being tainted. We don't know if people were doing things that they weren't reporting, as is the nature with clinical research.
Right. So you definitely need more research on it. But when you were doing the phase 1 studies in the animals, you were seeing some improvements with MS symptoms?
Absolutely. So the phase 1 trial, I was still, a student at Salem College, and I went down there and I kind of joined in. And so I had to catch myself up on all the research that they had done and sort of present it to the whole team to prove that I was worthy of being there, which,
we all know you were.
Right. So the initial phase 1 trial with the human subjects was supposed to be a year long. And after 6 months, people's symptoms had actually started going away. People stopped getting new attacks.
You're saying people here, not animals.
Correct.
Okay, wow.
Yes.
And they were taking a green tea supplement.
Yep.
Or ETCG.
Yeah.
What we thought was, okay.
Yeah. It's called polyphenol E is the specific one.
Wow, that's really cool. So just to be on the safe side, you're recommending, this is something great that I need to know, I think everybody else needs to know, you're just recommending get a good green tea, drink it. We know people have been drinking it for millennia.
Right.
It's not going to cause hepatotoxicity, so we can throw that away, and it will probably improve your symptoms of MS. It certainly can't hurt.
Right.
That's fascinating. That's cool. That's cool stuff. Whereas I have not seen that. I have not heard about it with getting your vitamin D levels up. I haven't seen where you get the improvements like that.
Right. I don't know. I'm not familiar with any vitamin D studies or really any other comparable nutraceutical for that matter. I mean, I've seen some work, on ginseng and ginkgo in terms of memory and cognition, which is also a major problem in MS. But in terms of, so there's this magic term in neurology, right? Neuroprotective. And people, neuroscientists are very protective over this term, neuroprotective. And it's kind of like if you're pregnant, you either are or you're not. There's no in between. There's no gray area. Something is either neuroprotective or it's not.
Right.
And so one of the things that the study that I participated in, which by the way, I guess I should just say was the study was conducted by Jesus Lovera down in New Orleans at LSU. He is an amazing researcher and continues doing MS research. He's one of the foremost MS doctors in the entire Gulf Coast. So I should just give a shout out to him.
Yeah, that's great.
He does amazing work. And so, the purpose of these studies was to establish the safety and neuroprotective effects of green tea. And so we were able to show, hepatotoxicity aside, green tea does definitively improve neuron metabolism, which means that they're alive and healthy. And we know that because of this molecule called N-acetyl aspartate, which is just an acetylated amino acid that is sort of the metabolic end product of healthy neuron function. And so what these trials were that we did, were looking at were the concentrations of NAA, N-acetyl aspartate, in the brain. And so we were able to definitively show that the higher the EGCG levels are, the higher the NAA levels are. And so this is why it works. This is how we know that it's actually neuroprotective and it's actually helping neurons function better.
So what I'm getting from you is that not only by whether you have MS or not, the green tea is going to help protect neurons. And then there seems to be, we don't know for sure, but based on the research that you've done, it seems to be that it can also help treat MS.
Yeah.
That's amazing. That's really, really cool. I don't think I certainly never heard of that. I don't think a lot of neurologists have heard of that either, conventionally trained neurologists, right?
Correct. Yeah.
And it can't hurt to do the green tea. So I guess my next question is, all right, so how much green tea? I have MS. How much should I be drinking?
Yeah, great question. So we were giving people 400 milligrams of the EGCG twice a day.
Okay.
And let's see, I found I was looking for my calculation. I kind of worked it out. So basically if people drink, let's see, there's something like 280 milligrams roughly of EGCG per tablespoon of green tea, which is a typical serving, a tea bag.
Okay.
And so you can basically just have, a double 2 or 3 times a day.
Yeah.
The decaffeinated green tea has significantly less, but it also has some EGCG in it. But the decaffeination process also denatures the molecule of interest.
Okay. Is there a particular type of green tea people should be looking for?
I don't know. That's a good question.
Oh, okay.
Yeah, I don't know if there's a difference in, and this would be a great, research question. Is there a difference between Japanese green tea, Chinese green tea, gen matcha, all these different versions? Is there one that has a higher amount of EGCG in it? Can we cultivate it? Can we breed our own green tea with high concentrations of these molecules? Probably.
So, but I'd imagine, we generally would recommend get an organic green tea if possible, right?
Absolutely. All things organic, especially now that we know how toxic Roundup is and we know how ubiquitous the use of Roundup is. Things organic.
Which can cause neurological symptoms in people, right?
Absolutely.
You have high concentrations of it.
Yeah, it's a neuroendocrine disruptor. And so any, again, depending on what your susceptibility is genetically, you can be affected anywhere along that entire, just not just one pathway, but really the whole network. That stuff's really bad.
Is there, before we end, I'm just fascinated by this, but is there any other nutraceutical that seems to have some protective effect? When you say EGCG or green tea, now I'm starting to think, well, what about curcumin? What about, that's an antioxidant. It seems to, when you look at the research on that, it seems to help everything. I'm not aware of anything on MS, but it seems to have this neuroprotective effect. And there's lots of other plant compounds, but are there any that stand out for you besides EGCG?
Not that I can speak of as clearly as the EGCG. But I will say that lowering your overall inflammatory load is going to decrease your risk for all-cause mortality and morbidity. The less inflamed we are, and we all know this, right? But the less inflamed you are, the better things can work. And that's not to say that the natural endogenous inflammatory processes aren't completely necessary. They are. You have to have an inflammatory process when there is an injury, because again, it's that breadcrumb that tells the nervous system, oh, there's a problem over here. Let's deal with it, and then let's clean it up. So without that inflammation, nobody's coming to clean up the tissue damage. So,
and that's why I think you mentioned, diabetes. That's an inflammatory disease. A cardiovascular disease adds to it. All these chronic diseases of these lifestyle diseases add an inflammatory component to it. So
smoking.
A lot of time, right. Smoking, right.
Yeah.
Not getting enough vitamin D. So it's like find the weak links there. Maybe you can improve the outcomes. But anyway, Brian, is there anything that you want to ask, or is there anything we missed, Blake?
I wanted to ask Blake, how'd you get into neuro?
Yeah.
What was it about neuro that attracted you to it?
Oh, wow. Well, I used to be sort of an athlete, and I got hurt, and I got better against all odds thanks to yoga. Mm-hmm. And I realized that my central nervous system was hyper agitated ever since the injury. And once I realized that I actually have the ability to calm my own, frazzled nerves, it changed my entire life. It changed everything. I mean, and in fact, I grew up more of like a writer, artist, using that part of my brain. And after the injury, my yoga instructor had told me, hey, you need to start using the other side of your brain. Start using your left hand as dominant, So when you sit there and you fold your hands over each other, genetically, we're predisposed to put, one thumb on top or the other. So she had me flip my whole system around. And after, doing yoga as a, wannabe lefty and meditating and all of these things, focusing on my left side, about a year and a half later, all of a sudden, I had a profound interest in learning math and science, and it started me kind of down this whole other
that's
trail.
Crazy. That's cool.
It like made my two hemispheres talk to each other. So I figure if I can do it, it's got to be within all of us.
Right. Awesome. That speaks to the neuroplasticity piece too, right?
Completely.
Where using your non-dominant hand or doing things a little bit different causes your brain to, grow and take over areas that are not necessarily always turned on. Right. And that was fascinating in the talk also, because I gave a talk to a few months ago to people who have strokes and who are dealing with it. And we talked a lot about the neuroplasticity. Right. And you mentioned, with these lesions in the central nervous system, especially in the brain area, I mean, if you utilize your brain in different ways and stuff like that, wherever the deficits may be, a lot of times your brain will compensate. So you can like walk around these lesions to kind of help yourself.
Exactly. The neurons that fire together wire together.
Right. Yeah, it's great.
And we even see transfer from one limb to another. So if you exercise your right arm, your left arm gets stronger, even just through imagining that and just exercising your right arm. So it speaks to that. It's all congruent.
Yeah, that's cool. Well, Blake, thanks so much for being on. I know this was spur of the moment. So Brian and I really thank you to be on. But fascinating stuff.
Yeah.
I didn't know that about green tea. That's really, really cool and a really easy thing to implement.
Absolutely. Thank you guys so much for having me on. This was really fun.
Have a good weekend. Thank you.
All right.
Thanks, Blake.